Hi there, today is the 3rd of September 2024, and in this video I'll be demonstrating how to build a basic Python app. But first of all, I'll just show you how my environment is set up. So what it is that first of all I'm using this terminal here inside Windows. I'm using Windows 10, and the actual terminal that I'm using is min-gw64. So what exactly is min-gw64? Well, it is the minimal GNU for Windows. So when we talk about Linux and programming in Linux, then that is based using the GNU library. And so what I've got here is basically a Linux shell, a bash shell that uses the minimal GNU libraries. So I can continue programming inside Windows as if I were programming inside Linux, inside the bash shell. And so where did I get this min-gw terminal from? Well, I got it from Git. So what it is that when we download Git for Windows by clicking on this link here from this website, git-scm.com, and then click on the Windows link, then not only will it install Git, it'll also install this min-gw terminal shell that will allow us to run Git inside the shell. But as well as that, we can use it as a proper bash shell inside Windows, and we can actually run Windows programs from inside this shell. So for example, if I type in Notepad now inside the terminal and press enter, it'll run Notepad like that. So this isn't SWL, this isn't a Windows subsystem for Linux. This is actually a bash shell that runs actually inside Windows proper. And we can run any commands from this shell exactly as we would run from a run command inside the Windows. So this is the min-gw shell for Windows that came with Git. And as well as that, I've also installed Python on my Windows computer, and so to do that we just go to the python.org, and then we just need to go inside where it says downloads and download the version for Windows. So I've got these two installed, and so after I've installed Git from this website here for Windows, then it'll create this icon here, or this shortcut to the git-bash. So once I click on that to begin with, then what we'll get is that we'll just get this screen here like that, which takes us to the very root folder of the git-bash environment. So if we do a pwd, it'll just say /, which is the actual location of the root inside the git-bash shell. In reality, this is actually located inside Windows under C:\program files /git. So this is the directory where we find ourselves in when we first open the git-bash shell. So now if we do a list of the contents of that folder, then it'll just give us the same contents as is showing inside the Windows Explorer if we compare them side by side like that. So these are the same files. So once we've opened up this git-bash terminal, the first thing that we need to do is to set up the environment, and we do that by going to the home directory of the user. So the home directory of the user is normally /user/administrator if we are logged in as administrator inside Windows. So to go to the home directory, then we just normally type in cd like that and then press enter, and then this tilde symbol here indicates to us the current directory. So this indicates to us that currently we are in the home directory. So if we do a pwd over here, then it says /c/users/administrator. So the reason why we logged into the root folder when we first opened the terminal is because we don't have a bash rc file set up or a bash run command file set up. So to do that, we just need to use vi or vim, and then vi, and then space, and then dot, and then bash rc, and then press enter like that, and then we can now enter the commands or instructions for the bash shell run command. So the first thing I would do is that when we first open a terminal, I would cd to the home directory of the user. So for that we would need to do a cd and then $home in uppercase. So this will take us to the home directory, and then what I would do next after that is that I would take a look at the the actual values of the folders which are set to the path environment. So currently, I'll just take a look as regards what is set inside the path environment. I'm looking to see whether we have the dot which indicates or represents the current directory. So it looks like we don't have that currently inside the path. So what I would do is that I would export path in uppercase equals, and I would just enter the double quotes dot and then colon and then double quotes again and then $path again, just to make sure that the actual environment searches for the current directory for any command prior to searching in the other directories in the path environment, so that whatever is located inside the current directory, if that is the command that we need to execute, that is executed first before any other command of the same name in the other folders in the path environment. And then, as well as that, I find it useful to know the time and the date. So I would place a date command there to output the date and time. And as well as that, I would create an alias so that we can easily access and edit the bash run command file whenever we need to, because I find that very often we might need to just add in or tweak the bash run command in order to add in aliases in order to help us do our work and save inputting commands unnecessarily when we can have it done using aliases inside the bash run command. So this one here, which I've called VIB, will open the bash run command file in the home directory, and then it'll run the source command on it so that it'll apply the actual settings in the bash run command to the current shell, to the shell that we're in, rather than having to exit the shell and having to open it again. We just automatically run the source each time we change the bash run command file. So I find that just very useful. So now, for example, if I just do a source on the bash run command file, and now if I just do a VIB like that, it'll open it up, and if I just exit this file, then it'll apply it automatically as well. So I find that very useful and saves a lot of keystrokes. And then after that, another thing that I would do is that I would just add the clear command at the start, so that every time we run this, we get a clear of the screen, so that we start with a tidy screen. And then after that, before starting any Python project, I would create a virtual environment. And I find that the benefit that we can gain from using a virtual environment is that we can have separate environments for different projects. So for example, if we're developing an application that requires one library, a certain library, then we can have that in that virtual environment only. And if we're developing a totally separate application that doesn't require that library, but instead require other libraries, then we can include those libraries in that separate virtual environment. And the great advantage of doing it like this, rather than having it all in the one environment, is that if we're using the py installer or py installer in order to build the executables, whether it is on the Windows platform or Linux, or whether we want to use the bulldozer to build the Android apps, because we're only using the libraries that we need, then that helps to keep the size of the executable small. So that is the advantage of using the virtual environments in order to produce or minimize the size of the final executable that we wish to compile from the Python code. So in order to create a virtual environment, we need to run, first of all, the command to create it, which is Python, and after that, -m, after that, venv for virtual environment, and after that, the name of the path to the virtual environment. So I'm doing this from the home directory, as indicated by this tilde symbol here. And so what I'll do is that I just now need to give the actual name of the virtual environment, and it'll create the actual folder with that name underneath the home directory. And I'll give this folder the name of Kivy for Kivy, and then today's date, which is 24/01/2015, 0903. So I know that I created this virtual environment for a specific application or project created on this date. So that helps me to differentiate between the different projects and the different virtual environments if I do it like this by giving it a date tag. And then I press enter in order to create it. So that took about 2 minutes to create the virtual environment, and it has created that, and it finished after that. And so if I now take a look at the actual contents of the folder of c:\users\administrator, we can find this new folder here with the name that I provided, Kivy 240903. And so this is the folder or the path to the virtual environment. And if we need to activate it, if we need to go inside it and set up the environment variables for that virtual environment, such as the paths in order to locate the packages in that environment or the libraries in that environment, then we need to run the script which is underneath the scripts folder. That is called activate. Therefore, in order to start up this virtual environment, we need to run this activate script, which is // and then the name of the virtual environment, which is Kivy 240903, and then scripts with uppercase S, and then activate with lowercase a, like that. And this will activate or start up the virtual environment. Okay, so it hasn't done that in this shell because it has done that in a separate shell, and that ended immediately because I didn't run the command with a dot. So if we wish to run a command or a shell script within the current shell and apply the actual settings to that current shell, then we need to first of all enter a dot and then a space and then the name of that that command or that file or that script. So here it is, it's dot and then a space and then dot to indicate the current directory and then the path to that script, and then I'll just press enter again. And so now we have this Kivy 240903 in brackets, and that indicates to us that we are now in the virtual environment for Kivy 240903. So now we can start developing our applications in this virtual environment and start importing the libraries that we need in order to build our application within this virtual environment. And so if we wish to just exit from this virtual environment, then all we need to do is just to type in the command deactivate. And so we no longer have the actual Kivy 240903 showing above the actual prompt here. So that indicates to us that we've exited from the virtual environment. And if we need to enter it again, then we just once again type in the dot and then the space and then dot Kivy 240903 / scripts with the uppercase S and activate again. And now we have re-entered into the same virtual environment. And we can create multiple virtual environments for each project that we are working on, and because each one will have their own different sets of libraries and packages that they need for that specific application. And to save us having to keep on typing the same activate command each time we need to go inside this virtual environment, then we can add it into the bash run command script by typing in the alias that we set up earlier, and then which is VIB, and then we can just add another alias, starting with the command alias. And then we can just enter the actual name of the virtual environment, which is Kivy 240903 equals and then single quotes, and then we just type in the dot and then space dot and then Kivy 240903 and then / and scripts, and then activate. Like that, and that will start up the virtual environment. So now if I just save this file, and now if I just type in Kivy 240903, now that has taken us straight into the virtual environment for that particular project. And so the next thing now that I need to do is to create the folders for that particular project. So I need to go inside first of all, the parent folder for this virtual environment, which is the KV240903, and underneath that I can create a folder called pyproj for all the different projects that will be inside that folder, and then inside that folder I can create another folder which is for the actual project itself. So I can call that project Hello World, like that, and I can go inside that project like that. And so each time I enter or start up the virtual environment, which is KV240903, what I can do is that I can take myself automatically into the relevant folder for that, which is pyproj. So for that, I can just add that into the alias for KV240903, which is after the activate command, I can just add in a semicolon, indicate that we now have another command, and then I can say cd, and then ./KV240903, and then / again, and then pyproj, like that, and that'll take me into the parent folder for the projects in that virtual environment. So if I save that now, so I'm now returned back to the home directory. So if I now type in KV240903, now it's taking me into that project, and I just need to go into the Hello World to go into that folder for that particular project. And so now I can start entering or typing the code for this Python project. So we start with the main.py, and for this, if we wish to just create a simple program that just outputs the word hello world, we can just type in print and then open brackets and then hello world, like that, and then close brackets. And then we can save it. And now in order to run it, we just need to type in Python and then main.py, and there it is. So that is our basic hello world program written in Python. So that was an extremely simple example, possibly too simple. So if we wish to perhaps elaborate on that and just do something a bit more complicated, then what we can do is, for example, we can create a class such as class we can call it class 1, like that, and we can assign a string, such as, for example, string 1 equals hello world, like that, and then we can create a function inside the class, such as show string 1, like this. And then for this we can use the command print and apply the string formatting inside the print statement, like that, using the syntax, which is the percentage sign and then S for string. And then after that we can just add in the variable name, which is string 1, like that. And because string 1 is declared as a class variable, then we need to make sure that it is included into the function using the global keyword and then the name of the variable, like that. And because string 1 has been declared as a class variable, then we need to add in the keyword self in front of the variable name, like that. And what we can do as well is that we can have the two different strings. We can have hello as the first string and world as the second string. So the hello can be the class string that is declared at the class level, and the second word, world, can be declared as a global string, like that. So we can have two strings in the print statement on line 5. So we can have hello, string, and then space, and then string again, followed by the exclamation mark. And as regards the second string, that can be string 2, like that. And because that is global, then we need to declare that as global using the global keyword within the function, which is global space and then string 2, like that. And then because we've got two strings in the print string formatting statement, after the percent symbol, we need to include these two strings inside the round brackets, like that. And also, because we have string 2 as a global variable, then the convention is to make sure that this variable name is in the uppercase, like that. And also like that. And then as regards the actual name of the function, it should conform to the actual Python style, which is that it should be in lowercase with the underscore used as the word separator. So what I'll do, I'll just change this to show underscore string 1, like that, and then save that. And then after that, I need to instantiate a class, and I do that by giving it a name, such as obj class 1 equals class 1, and then open round brackets and close round brackets. And then after that, I can call on the actual function within that object, which is obj class 1 dot, and then show underscore string 1, and then open and close round brackets, like that. And then I can delete the trailing new lines, like that. And then I need to remove the semicolons, because we do not use semicolons as the statement symbol inside Python. And then I need to save the file and exit, like that. And now to run it, I just type in python space main.py. And there it is. There is the hello world outputted onto the screen. And so after this, because this is a video about Kivy, we need to install the Kivy package or library. So for this, we need to use pip, which is pip. And after that, if we do a pip show and then enter Kivy, we just check to see whether Kivy is installed in this virtual environment. It shouldn't be, because it's a brand new virtual environment. So it's saying that the Kivy package isn't installed. So install that, we just type in pip and then install Kivy. And because we want to install the full Kivy rather than the base or the media, and so if we just want to have the base functionality, we can just install Kivy and then in the square brackets base, like that. Or if we wish to include the media library as well, then we can include media, like that. But if we wish to have the full base and media, then we can also instead of typing base comma and media, we can just enter Kivy and then full in the square brackets, and this will install both the media and the base packages for Kivy. And so we need to make sure that we're connected to the internet, and then press enter. And so the installation of the Kivy library has finished after about 3 minutes. So in order to test it's working fine, we can just change the main.py. So for this, we need to import the Kivy library. And to do that, we can just add in the statement from Kivy and then app, and then we can import app, like that. And then as well as that, we can import the label object from Kivy, like this, kivy.uix.label, import label. And then in the class 1, we can have a build function like that. Which is just the same as the previous function, which is the same as the show underscore string 1 function, like that. And then if we wish to comment out something inside Python, we just use the hash symbol like that. And then in order to run the class, we can just do class 1 like that, and then run like that. And we need to pass in the actual object of the Kivy app into class 1 like that. So now if we just save this and then once again run python space main.py, we now have this error message. So to fix that error message, I just need to change the parameter inside the build function to self, to add an extra L for self, like that, and then run that. Once again, python main.py. So here is the window, but it's blank at the moment. And if I close that, it outputs the words hello world onto the screen, onto the terminal console. So now if I just go back inside the source code and I change the print statement inside the build function to a return label statement, such as return label, and then I assign the text of that to be the contents of what's inside the brackets in the print statement, which is print, which is first of all the %s, and then space %s, and then exclamation mark, and then the rest is the same, like that. So now if I save this and exit, and then rerun python main.py, like that. And so now we have the hello world being outputted inside the window that has been generated from the Kivy library. And so that's about it for this video. Thank you very much for watching. I hope you enjoyed it and found it useful. Don't forget to share, like, and subscribe. And until next time, have a nice day.